Okay, let's take a look at number 9 on page 543. It's a non-ground ground. You're hiking in the wilderness, top of a cliff that is 60 meters high. And you fire something off from a stone, 21 meters per second, angle of 35 degrees. So VI, 21 meters per second, theta, 35 degrees. It's going to go up and come down. Okay, so in the x direction, we have VIX is VI cos theta, AX is 0, and it asks you how far from the base of the cliff you're looking for delta dx. In the y direction, VIY is VI sine theta, up, AY 9.81 meters per second squared, down, and delta dy 60 meters, and it's down. Okay, so what we don't know is the time, and once again we're going to find it in the y direction, and once again it's going to be the quadratic. So delta dy is equal to VIY delta t, 1/2 AY delta t squared. And so minus 60 is equal to 21 meters per second sine of 35 delta t 1/2 negative 9.81 meters per second squared delta t squared. Okay, rearranging, bringing these guys over, so we'll have 4.905 meters per second squared delta t squared minus 21 meters per second sine of 35 delta t minus 60 meters equals 0. And so then delta t is equal to negative 21 meters per second sine of 35 plus or minus the square root of negative 21 meters per second sine of 35 squared minus 4 times 4.905 meters per second squared negative 60 meters divided by 2 times 4.905 meters per second squared delta t equals calculator 21 times the sine of 35. So this is 12.0451 meters per second plus or minus. I'm going to go, I'm going to cheat here. 29 times sine of 35 squared. So I'm going to do all the under root at the same time. So plus 120 times 4.905. So under the root, I think, unless I screwed it up, you get 733.6846 meters squared per second squared over 9.81 meters per second squared. And so when you take the square root of that, oh, I think I screwed it up. All right, let me try that again. 21 times the sine of 35 squared plus brackets 4 times 4.905 times 60. Yeah, I did. Ignore this number. You get 1322.28 meters squared per second squared. Okay, and so then that gives us a time of 12.0451 meters per second plus 12.0451 meters per second minus, and this is going to be over 9.81 meters per second squared, 9.81 meters per second squared. So when I take the square root, you get 36.363 Obviously this one is not going to do it. So this one gets canceled out. We'll use the plus one. So add your 12, divide by 9.81, and you get a time of 4.9346 meters per second. No, just seconds. And once you have that, then do delta dx is equal to vi cos theta times delta t. So delta dx is equal to 21 meters per second sine of 35 times 4.93, etc. Okay, and so we multiply that by 21 times this cos of 35, and you get 84.8. So delta dx is equal to 84.886 meters. All right, that's number 9. Number 10. Says baseball player hits a ball giving an initial velocity of 41 meters per second at an angle of 47 degrees above the horizontal. It's a home run, and it's caught by a fan in the stands. So it goes up, and on its way back down, it's caught here. Okay? The vertical component of the velocity of the ball when the fans caught it, so the VFY is 11 meters per second going down, and it wants to know what's the height. So if we separate into x and y, this will be vi cos theta, and ax will be 0. But in the y direction, VIY is VI sine theta, and we can find it, up. 8y, 9.81 meters per second squared, down. And VFY is 11 meters per second, down. And it wants to know how high in the stands, delta dy. Don't need to even find the time this time. Just use VFY squared is equal to VIY squared plus 2AY delta dy. So delta dy will be equal to VFY squared minus VI sine theta squared over 2AY. So delta dy equals negative 11 meters per second squared minus, what was it, 41 and 47? Yeah, 41 meters per second sine of 47 squared over 2 times negative 9.81 meters per second squared. So delta dy equals, you're going to end up with a negative here, but that's okay. Maybe minus bracket 41 times 47 sine, close the bracket, squared, equals. So you get on the top a negative 778.13. So you get a negative meter squared per second squared, but you also have a negative on the bottom. So negative 19.62 meters per second squared, divide, you'll get a positive, and it should be 39.66, I think, if you don't round at all. And it works out to be positive because you end up higher up than you began up. All right, last one. I probably won't have time for it. Number 11, during a baseball practice, you go up onto the bleachers to retrieve a ball. You throw it back into the playing field at an angle of 42 degrees above the horizontal. Okay, so you're up here. You throw it down. Angle 42 degrees above the horizontal. What will the velocity of the ball be when it hits the ground? The velocity is 15 meters per second. And the height is 5.3 meters.